What's up guys, Mizzo Frizzo here, and in this Unreal Engine 5 beginners tutorial I'm going to go through everything from opening up Unreal Engine 5, creating a new project, navigating the viewport and details panel and content browser, just to name a few. We're going to look at adding content to our project. We're going to open up blueprints and start familiarizing ourselves with blueprints and components inside of blueprints, variables. We're going to look at a few handy nodes in blueprints, and we are also going to create a couple of different actors, a moving platform and a lightning pad, and I'm going to show you a couple of ways of interacting with a blueprint such as the lightning pad, and we're also going to jump into animation blueprints, sort of how they work and what they do. So what I'm hoping to achieve with this tutorial is to make a sort of comprehensive introduction to Unreal Engine 5 for beginners who are only just starting out. I'm very excited to share this with you guys, but first, a quick word from my sponsor. As per usual guys, this Unreal Engine 5 tutorial is brought to you by you, my generous subscribers and viewers who have been so supportive over the past 12 months or so. If you find this video to be of any use or value whatsoever, please hit like and subscribe, and if you're so inclined, please do consider making a small donation to the channel via my Patreon. Link is in the description. I do also have some very exciting news for you guys. I have created a Discord. It is called Mizzo's Dizzo, and the first 150 people to sign up for a membership on my Patreon will receive lifetime access to Mizzo's Dizzo, even if you immediately cancel your membership. So with a one-time payment of $10, you will be made a permanent legacy member of my Discord. I will send you an invite link via Patreon and we'll get you onboarded and you'll be a permanent member of Mizzo's Dizzo with just one payment of $10. Do jump on this, guys, if this interests you, because I will not be extending this offer. It will only be offered to the first 150 people who sign up via Patreon for that $10 membership. But without further ado, guys, let's jump into this tutorial. Alrighty guys, when we first fire up the editor, we're presented with this, and if we head to the Games tab here, you can see that we've got a couple of templates that we can create our project using a template. I'm going to select the first person template and blueprint. We're not going to be doing any C++. We don't need starter content or ray tracing, and hit create. Now that the editor has fired up, I'm going to walk you through what we're seeing here. So this main window here is called the viewport. It is sort of a 3D representation of your level and everything in it. And to navigate in the viewport, we can hold down the right mouse button and move the mouse to look around, and while we're holding the right mouse button we can use the W, A, S and D keys to move forward, left, back and right, much like any first person shooter, and you can also press E to move up and Q to move down. And while you are holding the right mouse button you can also scroll the mouse wheel to adjust the camera speed. So if I scroll it down, you can see we've got a much lower camera speed, and if I want to move much quicker, say I want to move to something much further away, I can scroll up and change my camera speed to be quite high. I'm just going to bring that back down again. We can also hold the left mouse button and sort of move through the map like so, and we can still use the W, A, S and D keys the same way, and E and Q to move up and down, but the left mouse button is a little bit sort of less intuitive, I guess. It might be useful, for example, if I just wanted to move, I wanted to keep the same perspective but move on the map, I can hold the left mouse button and sort of stay at the same height like so. Within the viewport, we can click on actors and objects in the map to select them, and you'll see that this little gizmo with these arrows will appear. And this, if we click on one of the arrows and drag, we can move the item within our level. We can also, up here, click on these icons right here, the next one changes this to the rotation widget, and now we can rotate this item on several axes. The next one here is scale. We can also scale our object on different axes, and I'm just going to press Ctrl Z to undo that. And if I switch back to the transform or translate widget, the location widget, another thing we can do here is click on this next little icon here, which if we highlight it says cycles the transform gizmo coordinate systems between world and object space. So you can see right here that this widget is aligned with the world's X, Y, and Z axes, and will move the object along those X, Y, and Z axes. But if I click this icon and change it to object space, you can see the gizmo is now aligned with the X, Y, and Z axes of the actual object, and will move it along the axes of that actual object. I'm just going to change this back to world space, and this applies to rotation as well. So this is rotating it on the world space. So you can see there that I can't really rotate the object straight onto its side, but if I change this to object space, I can now rotate that object onto its side like so. To move between these three different gizmos, the translation, rotation, and scale gizmos, I can also use the W, E, and R keys. So the W key will change to this translation gizmo. If I press E, it will change to the rotation gizmo. And if I press R, it will change to the scale gizmo. And if I change back to the translation gizmo, what we can also do here is we can highlight these little angles between two axes, and we can move this or rotate this or scale this on multiple axes. So I can move this on the X axis and the Z axis like so, or the X and the Y axes like so. And I can also select all three, although in translation mode I cannot select all three. If I go to scale mode, I can select two axes to scale this on, or if I wanted to scale the whole object and keep the exact same ratio, I can highlight the middle and select all three axes like so. Couple of other shortcuts that may be handy for you guys is if I'm moving this object and I want to move it quite far, I may want to hold shift, and then when I move it, the camera will lock to that object as I move it. So if I wanted to move this over to the other corner of the map, what I could do is highlight these two axes and hold shift, and then I can move this wherever I want and the camera will follow. I can also hold Alt, and if I hold Alt and click and drag, it will make a duplicate of that object like so. So if I wanted to put several of these around the map, what I could do is hold Shift and Alt, and I could click and move that. And then if I release Shift and Alt and press them again and click again, I could make as many copies of this around the map as I like. Just going to go ahead and hold Shift and select all of these and press Delete to delete them. And one other very quick sort of viewport hack I want to give you is the ability to focus on an object. So if I select an object over here, for example, and I press F for focus, it will pull focus onto that object. I can also hold Alt, and if I hold Alt and click and drag, I can sort of revolve my view around that object. I just want to move on to introducing you to these other tabs and windows that you can see around the viewport here. Now, if you do not see the content browser down here, what you need to do is hold Control and press the space bar, and it will bring up the content drawer like so. And what most people like to do is then click Dock in Layout and dock the content drawer so that you have this content browser down here at the bottom of the screen. This is very handy. You will use it a lot, but you may also want the content drawer from time to time. So if you do, you just need to hold Control and press spacebar. For example, if you have a editor window open, so this is a editor window for an asset, and I wanted to access my content drawer, I can press Control and space, and I've got access to my content drawer so that I can then potentially grab things that I need from here and drag them into my Blueprint editor. We're not going to go into blueprints just yet. We'll dive into blueprints in a moment, but I just want to continue familiarizing you with these windows and tabs that you see around the viewport here. So that's the content browser, and over here I've got the world outliner. And by the way, if you are missing any tabs or windows, what you can do is click up here on window and find the window or tab that you want to add to your editor. So maybe you accidentally close one of these tabs, such as world settings here. I'm going to close world settings. I'm going to close world partition as well. We're not going to look at that. But what I do want to look at with you guys in a moment is world settings. So I'm going to click window here and world settings and bring up that world settings tab. And I've got mine docked here, but you can make this a window if you like, or you can dock it up here, or you can dock it down there. You can dock it as a tab next to other tabs. So that's what I've done. I've just docked my world settings right here next to the details panel. So I'm going to go back to the world outliner here, and basically what the world outliner is a list of everything in the map here, and you can see that these some of these objects have been grouped into a folder, such as block 4 and cylinder. And this can be a way of just seeing what's in your world and finding it in your world. So for example, if I wanted to find this pickup rifle, I could click on it to select it and press F to pull focus. And there I've found the pickup rifle in my world right here. And if I wanted to find the player start, I could click on that and press F, and I've found my player start. The next tab I want you to look at is this details panel. And again, if you don't have the details panel or you've accidentally closed it, you can click on window and find the details panel in there. So the details panel is very, very useful indeed. It contains all of the details and configurations of different objects and actors and components in your world and within blueprints as well. So if I select this pickup rifle, you can see we've got its details here. We've got its location, rotation, its scale, and whether it's replicated for multiplayer, and all of these different settings right here. So you can change these in here. For example, if I wanted to change its location, I can use the gizmo as we looked at earlier, or I can, if I want to make its location a bit more specific, I can change it in here to something a bit more specific to exactly what I want it to be. So that is the details panel. And the next one I want to look at is the world settings tab. And this one is, you're not going to be using it a lot, but I do want to show you this in the world settings tab. We've got this game mode section with game mode override, and you can see that the game mode that is selected at the moment is the BP first person game mode. And if I drop down this section that says selected game mode, we've got some defaults within that game mode, such as the default pawn class. And a pawn is basically a character is a child of the pawn class. It is a type of pawn. And the default pawn class that we've got selected here is the BP first person character. So if I hit play up here, which initiates the play in editor, or PI as we like to call it, it will allow you to test your game in editor. And you can see here I'm playing with the first person character from the first person template. I can pick up this gun, and I've got this first person template gun. So I am playing as the first person character here. But what if you wanted to find this character's actual asset, its blueprint, and you didn't know where that was. So you see here I've got the first person folder open, but let's say I did not have that open and I wanted to find that character that I'm playing as. Well, I can look at the game mode override here. I can see what game mode I'm using, and within that game mode I've got this default pawn class, the first person character. And what I can do is click this little browse icon and it will browse to that asset, the first person character, BP first person character, blueprint class right here. If I open that up and head to the viewport here, you can see this is the character that I'm playing as. Now, I'm not going to jump into blueprints with you just yet. We're going to do that in a moment. But first, I just want to talk a little bit more about this game mode and this map that we've got here. So we've created this project using the first person template, but what if I want to add a third person character from the third person template to this project? Well, what I can do down here in the content browser is click add and add feature content or pack. And we've got this little pop-up here and we can select the third person content pack and click add to project. And you'll know this has been added to your project because you'll see a couple of new folders down here in the content browser, namely characters and third person. So we can close that now, and now we've got the third person content pack added to our project. And what I can do over here in the world settings is in the game mode override, I can change this to our third person game mode now that this has been added to our project. And you'll see that the default pawn class within the third person game mode is the BP third person character. So if I hit play now, we are now playing as the third person character, like so. Now this, as the name suggests, is an override, and it overrides the default setting of the game mode within our project. And if we wanted to change this permanently, what we could do is go up here to settings and project settings, and then over here under project we can look at maps and modes, and right here we've got the default game mode, and as you can see here it is set to the first person game mode. What I can do is I can change this to the third person game mode, and here we also have the default editor startup map as the first person map. So if I wanted to change this to the third person map, I can go in here and find the third person map, and this is the default level that will be loaded when you start up the editor. That is not to be confused with game default map. This is the default map that will be loaded when you first actually start up your game. So if you were to finish your game and package it, and then you fired up that exe and fired up your game, this is the initial map that would load. And you might set this to the map that contains your main menu, for example. I'm also going to change this to third person map. It doesn't matter too much. But now that we've changed the default game mode to the third person game mode and the editor startup map to the third person map, what I'm going to do is now close the project settings, and I'm going to hit save all right here and save everything. And I'm going to close my editor and restart it. And now that my editor has restarted, you'll see that it has loaded a different map. It's loaded the map from the third person template, and over here in the game mode override, you can see it's set to third person game mode, and within the third person game mode, I've got the BP third person character. So if I hit play now, we have the full third person template project. I have effectively changed this project to the third person template project, although we still do have, if you look down here in the content browser, the content from the first person template pack. So the first person character blueprint and the weapon and the arms and everything is still down here. What we might do now, guys, is start to familiarize ourselves with a blueprint. So what I'm going to do over here in my default pawn class here of my selected game mode is browse to this character blueprint, BP third person character, and open this up. And I'm just going to grab this tab and dock it up here next to my map. So I've got my map in this tab right here, and I've got my characters blueprint asset editor open in this tab right here. And what we're first presented with is the event graph. I'm going to go into this with you in a moment. We've also got the details panel over here for whatever we have selected. And here we also have the components tab. And this is all of the components that this blueprint is made up of. If you want to sort of get a better idea of this blueprint and its components, what you can do is head over to the viewport. So you can see we've got the event graph is open in this tab here. We can head to this viewport tab, and this is essentially a 3D representation of this viewport. You can select these different components inside of the components tab here. So we've got the root here is the third person character. That is the actual blueprint. And then the first one we've got here is the capsule component. We can select this here. We can select any components here, such as the character mesh, or we can click them inside the viewport here to select them like so. The capsule component is basically the root component of a character blueprint. It is basically the core component, and everything else is attached to this capsule component. So where the character moves, the capsule component moves, and everything else that is a child of it moves with it, such as the follow camera. And the reason for this is capsule component is basically a very simple shape that collides with other objects. So it might collide with a wall and it will not be able to go through the wall or other characters. And because it's this simple shape, it's just much easier to compute than, for example, collision on a very complicated skeletal mesh of a character. So this capsule component is the parent component, and all of these other components here are children of it. And you can tell that because they are slightly indented from the capsule component. And if I click this little drop down and pull this menu up and drop it back down, you can see that all of these components are children of the capsule component. Just very quickly, we'll run through what we've got here. We've got an arrow component, which is basically the direction that this character is facing is this way. We have the character mesh, which is a skeletal mesh. It is our character's skeletal mesh. We also have this camera boom, which you cannot see in the viewport, but if you select it, you'll be able to see it. And is basically an arm that the camera is connected to. That arm is connected to the capsule component, and then the follow camera, as you can see here, is parented to the camera boom. So the follow camera is then attached to the camera boom. And what we might do is just change some settings on this camera boom, just to give our game a little bit more of a gamey feel, because if we hit play, you'll see that the camera is sort of right behind the character. And I mean, no games really look like this, with the exception of maybe a top-down game where the camera is really centered on the character. A third-person game is not usually set up like this. So let's very quickly play around with some settings on our camera boom. What we can do is select the camera boom, and then over here in the details panel, we can have a look at some of the settings that it's got here. So here under camera, you can see we've got target arm length, and that is the length of this camera boom. We could change that from 400 to say 300 to make it a little bit closer. And then we have this socket offset, and this is basically an offset applied to the camera from this end of the target arm right here, the camera boom right here. So what we can do is we can change this socket offset to say 0, 100 to move it 100 units over to the right, and 100 on the Z to move it 100 units higher. And now we're going to have a little bit of over the shoulder action. And just to make this a little bit more fluid and feel a bit more gamey, is down here under lag, we can select enable camera lag, and this will just make the camera sort of lag a little bit behind our character's movement. I'm now going to hit compile up here, and compile is a button you'll be using a lot. So you might hear in many tutorials, they'll be telling you to hit compile and save. Compile and save. And this compile is compiling everything in the blueprint into something that your machine can read, and then saving it, obviously, I mean, that's saving it. You don't have to save all the time, but it is a good idea to save regularly and also hit save all every now and then, because if you have a lot of assets that have been edited and not saved, your editor might crash for some reason and you might lose some progress. And also, leaving a lot of assets unsaved may also cause your editor to crash. So if I hit play now, you can see we've got a little bit of over the shoulder action, and if I move, you see the character isn't locked into that part of the screen. It can kind of move around a little bit, and it's a bit more fluid because the camera is lagging ever so slightly behind the character's movement. Now, just a couple of tips for using the Play in Editor, or Pi as we call it. We can press F11 to full screen, and now I can play my game in full screen. I can also press F8 to eject from my character, and now I can move around just like I would in the viewport. I have ejected from the character, but as you can see here, my game is still running. My character is still animated. Anything that's happening in game will continue to happen. But if you want to pause it, if I just press F8 and go back into my character, what I could do is jump off this ledge and hit pause on my keyboard, and then I can press F8 to eject, and now I've paused my game and I've ejected. So this is basically for debugging and testing. You can test different parts of your game. You can pause if you need to catch a moment and see what's going on in that moment. You can do that. And if I press F11 here, you can see because I've ejected from my character, I can select different things in the world, and I can have a look at what might be going on with those objects at runtime. So another thing you can do here, if I hadn't ejected from the character, if I press F8 and I unpause this, I've got my character here. So I ejected from my character, and that allowed me to do this kind of thing. But another way you can do that is you can press Shift F1 and it will get your cursor back. So I have not ejected from the character here. You can see it's still sort of possessing the character, but now I can select different objects in the details panel in the world outliner and stuff like that. But because I haven't ejected from the character, you can see it's not highlighting anything. So this is more useful for if you have started up your Pi in a window and you just want to leave that window and open up something else somewhere and have a look at that. So you can press Shift F1 if you're in the Pi. You can see at the top left it says Shift F1 for mouse cursor. Press Shift F1, I can get my mouse cursor back. And if I click back in here and I press Escape, I can exit the Pi like so. If you don't press Escape, what you can do is press Shift F1 to get your cursor back, and then you can click Stop up here. And another way of starting the editor instead of pressing play is I can press Alt and P on the keyboard. If I press Alt P, I will start my Pi. If I press Shift F1 to get my cursor back, I can then hit Stop up here, and I've stopped that simulation. And the next thing I want to look at with you guys, if you head back into your BP third-person character, is this character movement component down here. You can see it's separated into another section by this line right here, and that's because this character movement component is just purely code. It doesn't have anything that's sort of represented in the 3D environment, such as these other components. It is purely just code, and it basically dictates, it contains a bunch of parameters and dictates how our character moves through the world, such as when they are walking or jumping and falling and whatnot. So if you select the character movement component and then have a look in the details panel here, you can see a bunch of different settings, such as the gravity scale here. So if I change the gravity to say 0.25, hit compile and press play, now when I jump, you can see that the gravity is now set much much lower. And there's other things you can set in there, such as this control that I have over the character while they're falling. You can change a bunch of different parameters to change how the character movement acts in your game. And the one we're going to look at now, if I just change the gravity scale back to what it was, 1.75, and we go down to this section that says character movement walking, you'll see one here called max walk speed. And this is the max speed that your character can run along the ground at. And you can see by default it's set to 500. And what I'm going to do now is change this to 150, hit compile and hit play, and you'll see now that my max walk speed is 150. And we're going to have a look now at changing this max walk speed at runtime using blueprints. So if we go back into our BP third person character and we go back over to the event graph tab, you'll see the event graph here. And just quickly, we'll have a look at what is in here, starting at the top here. So you can see by this comment that they've left for us that this section is to add an input mapping. And basically what it's doing is on begin play, which is when this blueprint is first loaded, this node will fire and execute everything off of here. And as you can see here, it's getting the player controller, and then it is assigning a mapping context to that player controller. And basically what a mapping context is context for in the game, such as you say you're playing a game like Grand Theft Auto and you jump into a car, your aiming and firing buttons have all of a sudden become braking and accelerating buttons. And that's kind of what this is. It's, when the environment changes and you change the mapping context to give your player sort of different inputs to do different things. I'm probably not explaining that the best. We're not going to jump into that more today, but I'll just give you a brief rundown of what a mapping context is. So basically these nodes of this color, these first ones you can see here, are called events. And when different events happen, they will fire off. An event begin play is a very common one. This one is fired off when this blueprint is first loaded. So when we begin play. You might want to run other things off event begin play other than just adding a mapping context, such as, say you have a system where you pick up weapons off the ground and you wanted your character to start with a particular weapon. You might take your logic that spawns the weapon in the player's hand when you pick it up and instead just run it on begin play and attach a starting weapon to a player's hand, just for example. If we go down here, you'll see we've got these other events, and these ones say enhanced input action, IA look, input action look. So this is basically an input action that has been created and bound to the mouse movement. And when we move the mouse, this is triggered. It takes the value on the x-axis and adds a yaw input, so makes us look left and right. And it also triggers this one, which takes the value on the y-axis and makes us look up and down. So when we move the mouse, these fire off and make us look around. Very similarly, IA move is when we press the W, A, S, and D keys. It is taking the inputs on the X and the Y axes and adding movement input to our character to move us around. And then we have IA jump, which is triggered when we press the spacebar and makes our character jump up and down. And what we can do is we can see this stuff in action by doing some live debugging. So if I grab this tab and just move it into a window like so, I can have this in a window here. And if I press play in my editor, you'll see that this box has come up around the blueprint and it says simulating. But up here, you can see it says no debug object selected. So we need to select this character right here. In this drop down, BP third person character 0, that's this one. We only have one. And if I click in the editor here and I move the mouse, you can see those lines lighting up on the IA look. If I press W, A, S, or D, you can see those lines lighting up. So we've got the mouse movement lighting up and the walking. And if I press space, you can see that bottom one firing. If I hold space, it just does the jump. And if I release space, it's doing the stop jumping, like so. So that is a very quick and easy way to start debugging. When you create a blueprint and you add some functionality, you can debug it by opening up your Pi and selecting a debug object, and then see what's happening in your code, like so. Alrighty, let's add some functionality to this blueprint. What we're going to add is the ability to jog. And it's going to be very similar to this jumping action where we press a key and it does one thing, and if we release the key, it sort of stops doing that thing. So what we're going to do is just right click down here in some empty space, and this is how you can bring up any number of nodes within the blueprint system. So there is literally thousands upon thousands of different nodes, all of which are bundles of code that execute when they are fired off. And what I'm going to look for here is just the left shift. You can see under here, keyboard events, left shift. And if we select this one, when we press the left shift key, this event is going to be fired off. And when we release it, this code on this execution pin will fire off. So by the way, these are called execution pins. And these pins right here are more data. I believe they're called data pins. So they pass different data, such as the target of, if we're going to call an event, what the target is. You can pass different variables, and we are going to start looking at variables in a moment. So anyway, when we press the left shift key, what we want to do is set that max walk speed inside of the character movement here. So what I'm going to do is just click and drag this character movement component out into the graph, and you'll see that we've got this character movement get node. This is called a get node. And then what we can do is drag off of the character movement and find set max walk speed. And we can plug this into the pressed on the left shift key, and we can change this max walk speed to whatever we want. I'm going to change it to the default that it was set at before we changed it, which is 500. And then what I can do is I can click this node and I can press Control C to copy and then Control V to paste it. Or if I delete this one, what I can do is I can just press Control D to duplicate. So I've duplicated that node so that I have another one. I can plug this one into released, and I can plug the character movement into the target and change the max walk speed to 150 upon released. So Control D to duplicate is a very useful thing that you will use a lot. Say I wanted to use this same logic again, get these same nodes again, I could select these three and press Control D to duplicate, and I've duplicated all three of those nodes. So this should be working now. If we press compile and hit play, see our character is walking, and if we press the left shift key, they are starting to jog. We can release the left shift key and they will go back to walking. Very nice. Press escape and go back to your third person blueprint. And now I want to start looking at variables with you guys. So down here, you've got the My Blueprint tab. You can see in the graphs section, we've got the event graph and then the different events inside the event graph. So if we wanted to move to any of these, we could double click them and move to the jump, move to the move action or the look action, or back down to our left shift. And down here, we've got functions. We have not created any functions yet. You'll see it's just got a reference to the construction script, which should be open by default here. And this is basically script that would run during the construction of this blueprint. So it's basically best to think of this as a little bit before event begin play. Event begin play is upon construction, and construction script is kind of best thought of as happening just before that. We're not going to go into that right now. We're also not going to go into macros or event dispatches just yet. We're just going to be looking at variables now. So I'm going to head back to my event graph here, and we're going to have a look at the different types of variables. So I can click this little plus icon to create a new variable, and you can see that it automatically asks us to rename the variable. I'm not going to rename this one just yet. I'm just going to leave it called new var for new variable, and you can see that by default it has made it of type Boolean. We can drop down this menu here and you can see we've got a selection of different types of variables, and again there are a huge number of different types of variables. I'm not going to go into all of the different sorts of variables, but I'm just going to look at sort of the most common ones that you will be using when you first start out. So Boolean is a very basic one. Boolean, if we highlight Boolean here, you can see it says true or false value. So it is literally just either true or false. It is 0 or 1. And what we can do here is we can drag this variable out into the event graph, and then it will give us the option to either get that variable or set that variable. So if we get the variable, it is literally just getting the stored value, which is going to be either true or false. And if we drag it out and we click set, we can set that variable as being either true or false. So for example, we could set it here as being true, and if I duplicate that node down here and plug it in here, we can set it as false. And then just like that, we very quickly have a variable that tells us if our left shift key is pressed or if it has been released, like so. So for example, when we press the right mouse button, you might make a variable called aiming and set it as true when we press the right mouse button and set it as false when we release the right mouse button. And then you would have a variable that tells you whether you are aiming or not, just like that. Now we can drag this out and select get or set, or to make things a bit quicker, what we can do is hold Control and click and drag this out, and it will give us a get. And if we hold Alt and click and drag this out, it will give us a set, like so. Now I'm just going to delete these. That's Booleans, and the next variable type I want to look at is integer. And an integer is just a whole number. So if I hold Alt and click and drag this out to get a set, you'll see that this will allow us to set this variable as an integer. So, 1, 2, 3, 4, 5. So no decimal place, it is just an integer, a whole number. And the next one I want to look at is float. And float is like an integer. It is just a number value, but it allows us to have a decimal place. So we could change this to 150.741962 if we wanted to. And while we are on the float variable, I want to just point out that this variable here in the set max walk speed is a float. So we could very well set the default value of this float variable and then plug it into this pin right here. So when we create a variable, it has a default value, and if you look over here, it will say, please compile the blueprint. We need to hit compile before we are able to set a default value for that variable. So what I might do is click on this variable down here, single click, and it will allow us to rename, or we can press F2 to rename it, and I might rename this to jog speed, something like that. And then if I hit compile, I can set the default value of jog speed to 500. And then I can hold Control and click and drag this out and plug it into max walk speed like so. And now when this code executes, it is going to set the max walk speed of the character movement component to this variable, which is the jog speed, which we've set to 500, like so. So you can create a variable, change its type to float, change its name, change its default value, and then plug it in like that. And another way that you can create a variable to tie this value to is just by dragging off of the data pin and selecting promote to variable. And you can see it has created a new variable there. And let's just make that one walk speed, like so. We can hit compile so that we can change the default value, but you can see that it has automatically made the default value whatever was selected in here when we promoted it to a variable. This was set to 150, and then when we promoted to a variable, it created a variable of the correct type and made the default value, this value here, 150. So walk speed, default value is 150. Jog speed is 500, and now this code will do exactly the same thing, but now we have access to this value as a named variable that we can use in our code. So later on, if we wanted to, set walk speed as 250 and then set max walk speed as that walk speed, we could do that now. So I'll just show you that in action actually. So this will now act exactly the same as it did before. If I hit play, my character walks. If I press the left shift key, they jog, and I release it, they go back to walking, so on and so forth. But now with this variable like so, what if I were to right click here and find the 1 key? You might have to type keyboard or keyboard event to find this, but you can see under keyboard events, we've got the 1 key here. And on that note, another way that you can change this key, if I just press Control D to duplicate this, and I select this other one, up here in the details panel, I can look at input and input key and click this little keyboard icon and then press the key that I want to change it to. So I've now changed that to a press of the 2 key. Now, what if I press the 1 key and I grab my jog speed here and I hold Alt and click and drag that out and grab a set node and I change the jog speed to 1000. And then I could duplicate this node, and on press of the 2 key, I could change that jog speed back to 500, like so. So when I press the 1 key, I'm setting this variable, jog speed, to 1000. And if I press the left shift key, it's going to grab that variable and set the max walk speed as that variable there to 1000. So I'll hit compile and save and hit play. If I press the left shift key, it is just changing the max walk speed to 500. But now if I press the 1 key and I now press the shift key, it has changed our max walk speed to 1000. So I've changed that variable jog speed to 1000. So when I press the left shift key, it's setting the max walk speed as that value. And if I press 2, it will change it back to 500. The next thing we can do here is look at a print string, and a print string is a very good way of debugging. You do want to get used to using print strings. They will be very useful to find out what's happening in your code and debugging. So if on the press of the 1 key here, I now find a print string. We've got this print string, and by default, it will just print hello. And if I drop this down, you'll see that it's going to print it to the screen, print it to the log. It's going to print it in this color for a duration of 2 seconds. And this is just the name of the key. If a non-empty key is provided, the message will replace any existing on-screen messages with the same key. This doesn't matter too much. For now, we just want to look at maybe changing the color to yellow, and I'm going to make the duration 5 seconds. And now when we press 1, it's going to change the jog speed to 1000, and it's also going to print this string hello on the screen. So if I press 1, I'm just going to wait for the Shift plus F1 for mouse cursor to disappear. And now if I press 1, you'll see it says hello, 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 and that will stay there for 5 seconds before each one disappears, like so. But what if we don't want it to say something specific? We want it to print the variable jog speed on the screen. Well, what we could do is we could just plug this data pin into the in string right here. So this input is also this output. It outputs this number. Whatever it has set jog speed to is output here, and we can then print that on the screen like so. And if I collapse that and I just duplicate these down here, I can also plug in this one. And now when I press 1, it will tell me that my jog speed is 1000. And if I press 2, it will tell me that it is 500, like so. So that is a print string. And I think that's just about enough of floats for now. I'm going to delete all of this, and then down here in the variables section, we are going to have a look at some more variable types. So I'm just going to add another variable, leave it called new variable, and drop down this types menu and have a look at some more of the types here. So we have name, and that is basically the name of, it could be a name of an actor or a socket, or it's just a generic name. It is typically all text. We have a string, which is a combination of basically text and digits. A string is just a string of text and numbers basically, and we have text as well. And then down here, and these are the ones I want to focus on, we have a vector, a rotator, and a transform. Now we will have a look at some examples of all of these, but basically a vector is a three-dimensional coordinate. And there's a lot here to go into. You may want to actually spend some time on vectors and vector math, because you can add vectors and you can multiply vectors and you can do some pretty funky stuff with vectors. A lot of math involved there, which can be a bit tricky to wrap your head around, but basically a vector is a coordinate. So if we go into our map here and I select an object, say this cube, and then have a look in the details panel over here, you can see the location of this cube, and this is the world location of this cube. So I happen to know that the origin of this world is right here at 0, 0, 0, and this cube is at location 1150 on the x-axis, 2050 on the y-axis, and then about 50 units up on the z-axis right here. So if I grab this cube and I start to move it, and you look in the details panel down here, I'll grab it on the x and the y-axis, you can see its location changing there in the details panel. And if you wanted to set that more precisely, you could just set it here as 1000, 2000, and maybe, I don't know, 75. Whoops, 75. And you've set that location more precisely. So a vector can be thought of as a sort of three-dimensional coordinate. And like I said, there's a lot to dive into there, and there's math and whatnot. But just very briefly, what I might do is hold Shift and Alt and make a duplicate of this cube and put it over here. And I'll just put this cube about here. And when we select these cubes, you can see their location in the details panel right here. And like I said, that location is relative to the origin of the world over here. But you could do math to figure out the vector, say, between this object and this object. What you could do is subtract this object's vector from this object's vector, and you would get a vector that runs from here to here. So you could get the relative location of this object, compared to this object right here, if that makes any sense. So if you subtract the vector, it would subtract the x off of the x and the y off of the y and the z off of the z. So if we made this, for example, 500, 1000, and 50, and we made this one 1000, 1575, like so. If we were to subtract this vector from this vector, we would get a vector 500, 525, because that's the difference on the x and the difference on the y and the difference on the z. I hope that's not too confusing for you guys. We will look at sort of more examples of vectors in a moment, but that's just basically the best basic description that I can give you of a vector. And here we have rotation as well, and if we look in our variable types, we have after vector, we have rotator. So very quickly, just before I go on to rotators, what I might do is select vector, hit compile, and then have a look in the default value right here. So this is another good way of getting used to what these variables actually are. So vector is essentially 3 floats on the x-axis, the y-axis, and the z-axis. So you can see here, default value is 3 values right here. You could drop this down and you can have a look what the x, the y, and the z are right here. And if we change this to a rotator and hit compile, you can see again that these are basically floats, and we've got them on the x, the y, and the z axes, but now these are a rotation. These are rotation arguments. So just the same as we've got the location here, we've got the rotation, and we can play around with the rotation of these objects. That is what a rotator variable is. Now, a transform is a combination of vector, rotator, and also a scalar. So if we select transform and we hit compile, you'll see over here we have the default values of this transform are location, rotation, and scale. So this contains basically both of these, a vector, a rotator, and also a scalar. And if we look at the details panel of our object under transform, it has those 3 right there: location, rotation, and scale. So that is the transform of that object. And what I'd like to do with you now is just create a new component in our character, and we're going to play around with its relative transform. So first it's relative location and its relative rotation. So I'm just going to delete this new variable that we created here, and I'm going to go to the viewport so I can better visualize this. And all I'm going to do up here in the components tab is add a new component, and we'll make it a static mesh component. Now I'm just going to call it cube, and I'm going to leave it parented to the capsule component like so. And over here in the details panel with my cube selected, I can select a static mesh. And if we scroll down here, we should be able to find a cube. This is just part of the in-engine content here. And I'm going to change its scale, make it a bit smaller. So what I can do is click this little padlock here on scale, and this locks the ratio of the scale. So if we change one axis, it will change all of the axes to stay in ratio. And I might just try 0.4. That looks good. And I'm just going to move this around using the widget here and put it sort of in front of our character and over to the side a little bit like so. And what we're going to do is we are going to bind some logic to the 1, 2, 3, and 4 keys on our keyboard, and we're going to change this cube's position inside of our character. So what we're going to be doing is changing the relative location of this cube. And just before we go on in a moment to talk about world location versus relative location, they are both essentially relative locations, but this cube's relative location is relative to the root of this character. So if we select the cube here and we just click this little undo arrow to reset the location to the default 0, 0, 0, you can see that cube is at 0, 0, 0 now, and that is the kind of root that is the origin of this blueprint. Kind of looks like our character is wearing a cardboard box as a pair of pants. That's kind of cool. But the difference between relative and world location is very subtle. So this location is relative to 0, 0, 0 inside this blueprint. And if we were to change something's world location, it is essentially just a relative location relative to the origin of this world. So they are essentially both relative locations, but we treat them kind of differently. So what we're going to do is first go to the event graph in our third person character, and we can start by creating a few variables. I'm going to create one, and I'm going to call it, say, box location 1. And it is going to be a vector, because remember, vector is essentially the location of an object. We can duplicate this and call the next one box location 2. We can duplicate it again, and I'm just pressing Control D here to duplicate, and make it box location 3 and box location 4. And if we compile now, what's this? Cannot pass value 0, 0, 0. That error should go away if we compile again. I don't know why that error was appearing. So what we can do after compiling is we can set the default value of these locations. And what I'm going to do is go back to the viewport here, and this current location here of the box, where I've just put it out to the front and to the left a little bit, I'm going to use this location for my box location 1. And what I can do is look at the current relative location up here in the transform in the details panel of my cube, and I can right click on that and copy that location. And then if I select box location 1, I can right click over here in the default value and paste in that location into the default value of box location 1 here. And then what I'm going to do is I'm going to grab this box, I'm going to move it up to say here, and then I'm going to again copy its location, go to box location 2 and paste that location into the default value of box location 2, and so on and so forth. Move it over to the right click, copy the location, save that as the default value of my box location 3, and one more time, right click, copy that location, set it as the default value of box location 4, and hit compile and save. And I'll just leave the box there in box location 4 for now. And then what I'm going to do is go to the event graph. I'm going to right click in some empty space and find 1 on the keyboard. I'm going to duplicate this 3 times so that I have 4. I'm going to click on the second one and click this little keyboard icon and press 2 on the keyboard to set it to key 2. And the same here, key 3 and key 4. So we've got 4 button presses, 1, 2, 3, 4. And now what we can do is get our component from the Components tab. So I can grab my cube and drag it out here. And I can drag off of it and set relative location, like so. Set relative location. Plug this in here. And what I can do is take my box location 1 and plug it into the new location, like so. And that's all we're going to do here. I'm just going to make a bit more space here. And then what I can do is select these and press Control D to duplicate. Actually, I probably shouldn't duplicate the box location 1, but that's okay. This might be a good example to show you what you can do here. I can grab box location 2 and just drag it onto that get box location 1 node, and it will change node to box location 2, like so. So again, I'll duplicate this 2 more times, position these so that they're neat enough to read, plug these into the execution pins here, and I'm going to change this one to box location 3 and this one to box location 4. If I hit compile and save and I press play now, you'll see we've got this weird box that follows us around everywhere we go. And if I press 1, it will change its location to box location 1, 2, box location 2, 3, and 4, so on and so forth, and I can change between any of those. Now, this is obviously not a game mechanic that you would put in your game, but this is just to give you an idea of relative location and rotation. So we'll go and we'll do rotation now, and it will be very similar. I'm just going to, actually, I'll leave these here for now, and I will pull up the R key. So the R keyboard event, and I'm going to use this to set the rotation of our cube. So I can get the cube and I can set rotation, and it will be set relative rotation. And if we press this and we put in a rotation here, let's say we rotate it 45 degrees on the X and Y axes. If we do that, it will change this to its rotation, and it just won't change again because it's already set as that. So 45 degrees and 45 degrees, we've changed its rotation. But what if we get the cube's rotation? So get world rotation, get relative rotation. What if we get the relative rotation and we can right click on this and split the struct pin, and we have 3 values here, the X, the Y, and the Z. We can also do that here. We can right click and split the struct pin, and this is basically just broken down that rotation variable, that rotator, into 3 floats. So the 3 different axes. And what we can do is just say on the X axis, we can drag off of here and find an add node, add, and just add 45 to the current X rotation and set the X rotation as the new current. So it's going to get the rotation and set it as that rotation plus 45 on that axis. So we can duplicate this node and also do it with the Y. And then if I just plug the Z into the Z here, it will make no change to the Z. So now, every time we press R, it should add 45 degrees to the X and 45 degrees to the Y. Now, I just want to start looking at doing this on tick. So tick is basically every single frame that your computer generates of the game. It will run that operation on every single tick. And I don't think we have any tick operations by default here. So what we can do is just right click here and find event tick. And this is another event that is fired off every single time your computer generates a frame of your game. So many, many times per second, depending on your computer. And this is going to be quite a good example of how this works, because what we are first going to do is let's just do this rotation, but on tick, and watch what happens. So if I just grab this set relative rotation and I run this every time my computer ticks, I've got a pretty powerful computer. So yep, you're going to see that this cube is spazzing out. It's rotating very, very, very quickly. But what you can do to tie this to time is we can delete this stuff here. And what I'm going to do is just get time seconds. And I'm going to multiply this by 45 and plug this into the X and the Y. And now every time my machine ticks, it's going to set the relative location as this rotation here, which is just the amount of seconds that have passed multiplied by 45 degrees. So it will rotate by 45 degrees on these two axes every 1 second. So if we hit compile and save and hit play now, we should see that in action. And now that is rotating much more smoothly. It's still rotating on tick, and that's why it looks so smooth, but it is sort of, taking time into account in that calculation, and so that's working like that. And just before we move on to some world location stuff, guys, I just want to give you one more tip with sort of vectors and rotators, and that is sort of make and break vectors and rotators. So if I just find a make rotator, you'll see that this node takes 3 floats and outputs a rotator. So what I can do is I can disconnect these, and I'm holding Alt, by the way, and clicking. If I hold Alt and click, it will disconnect those connections. And also on that note, I can hold Control and click and drag an execution line onto a new execution pin like so. So Control to move an execution line, and Alt clicking deletes a connection. And I'm just going to Control Z to undo that. And I'm going to right click on these pins, and I'm going to recombine the struct pin. So you can see the color difference here between a rotator and a float. And this can now plug straight into that new rotation without splitting it. But basically that's what this does. It makes a rotator from 3 floats. It recombines them into a rotator so that I could do something like plug these in here like so. So if I hit play, that's going to have the exact same effect. And you can also, you can also break a rotator, and that has the exact same effect as when I right click on this and I split the struct pin. It has that exact same effect, although these are input data pins and these are outputs. So perhaps a better example would be to create a new variable. I'm just going to leave it named new var and change it to a rotator. If I get this rotator variable, I can right click on it and I can split the struct pin into the X, Y, and Z. Or if I recombine these, I can use a break rotator. I can use a make rotator to recombine them if I want. And then that output is a rotator. And you've got the exact same thing with, you can break a transform into location, rotation, and scale. I can drag off of this and I can break vector, and this break rotator is what would break the rotation. And you can also break vector on scale. So scale is a vector just because a vector is 3 floats and it's on 3 axes, so scale is also a vector. And you've got make vector, you've got make rotator. So you can use these. Obviously, the example I've given here is that it's exactly the same as, for example, right-clicking on a pin and splitting, right-clicking on a pin and splitting the struct pin. It is basically the same as that. But there are instances in your code where you might want to make a rotator, make a vector, make transform. But yeah, I just wanted to make you aware of these nodes. And now what we might do is look at changing the world location of an object. And how we can do that is I can just delete this wall from the back here, and I'm going to create a new actor blueprint. So I'm just going to go to the content folder here and just create it inside the content folder. I'm going to right click and go to blueprint class and make an actor. And I'm just going to call this BP underscore platform and open this up. And straight away, I'm going to add a static mesh component and I'll call it platform. And then I will grab a cube, and I'm just going to scale this down, and I might switch off snapping here. So this is a good moment to introduce you guys to grid snapping, rotation snapping, and scale snapping. So if I want to move this around, you can see it's moving in increments of 5. And what I can do is change the snapping here to say 100. And now this will move in increments of 100, so 1 meter, and so on and so forth. You can change how much it snaps by, and you can also click this one here to switch off snapping and give you an infinite amount of control. And what I'm going to do is turn off snapping for scaling, and that way I can scale this down, make it a bit flatter, and I'm also going to grab these two axes and just make it a bit bigger, like so. And now that I've added this cube, I'm just going to add this actor in the world by going back to my level here and dragging out this platform like so, and just going to move it off the ground a little bit. And I think I'm going to make it a little bit bigger than this. So I can just scale this up and have a look. Maybe a little bit too big. That'll do, like so. And what we're going to do inside of this blueprint is change its location on tick. So what we can do is go to the event graph, and you can see we've already got event tick here, and I can get my platform, and I don't actually need to do this. I can just move the whole actor, so the target will be the self, not any specific component. It will just move the root. So I can just set world location. And I'm going to get the world location and split this struct pin, also split this struct pin, and I'm going to leave the Y and the Z the same. And what I'm going to do is just add, say, 10 units to the x-axis every tick. But as I explained earlier, because this is happening on tick and it's not bound by time in any way, it should just fly off into the sunset. It's not going quite as fast as I thought it would. I have locked my frame rate to 60 frames per second, and that could be why. So if we make this 100 and see what happens, it should be a lot faster. It'll fly off a lot faster. So what we can do is bind this by time, and I'm also just going to give you a quick example of what happens when we don't get the current world location and add to it. So if I get rid of this and I just get time seconds, and I multiply this by, say, let's just make it 50, and set this as the new location X. Now this will make it move 50 units forward every second on the X, but its location will not be sort of where I placed it here, because it is going to place it 50. It's going to start placing it from this world origin over here. So if I hit play, you'll see it's disappeared. And where is it? It's over here. And it's going forward by my 100 units per second, like so. So what if we want to bound it by time, but we want to start our platform over here where we placed it? Well, all we'd have to do is add this number to the initial location. So we do just need to sort of get that initial location and save it as a variable. So we can call this a start pos. Oops, got caps lock on there. Sorry about that. Start pos. And I'll make this a vector. And what I'm going to do is get this start pos and add this to the start pos and set that as the new x. Sorry. I will need to split this. So I do need to just disconnect this, and I can right click and split this, and I'm going to just get the x. Sorry about that. This, I may need to replace this addition node because it's trying to add a vector. Nope, not compatible with, this is multiplying a vector. My mistake, guys. That's just because I called up these math nodes sort of off of vectors and whatnot. It changed the pins to expect a vector, and I was trying to, add a float to a vector. It doesn't really work. So we're all just working with floats here because we split this, and this x and y, y and z can stay the same as this start pos like so, but we do need to set this, the default value of this start position. So we can go back to our level and look at the position here and just right click on that and copy that start position, and I can paste that into the default value of the start position like so. And now if we hit play, it should start where it starts, and it's moving off at a very smooth 100 units per second, like so. Nice. Okay, what's next? Now guys, say you wanted to move this platform back and forth between 2 points. So let's say you've got another platform, and what I might do is just grab the floor here, and if I hold Shift and Alt and move it on this axis, I can just drag out another duplicate of the floor there. And I'm also going to take our platform and move it over here. And I'm also going to grab this player start and move it here so that we start over here. Now, if I wanted to make this platform move back and forth between these two sort of levels here, I could go into my blueprint and I could do a bunch of math with a start position and an end position and have it move back and forth between those two positions. But the beauty of Unreal Engine 5 is that they've thought of a lot of things that you might want to do and have in your games, and they have given us the sort of functionality all built into the engine. There is a lot of stuff that they've thought of for you in this engine, which is why it's so fantastic and makes game development just about as easy as you could possibly imagine. It is still very complicated and a lot goes into it, but they have made it as easy as you could hope it to be. And one of the things that we can do is just delete this logic here, and we can add a component, and I believe it's called interp to movement. So this is an interpolation to move this blueprint. And what you can do is select interp to movement, and you've got a whole bunch of settings over here that make this just basically make this into a moving platform with very little work. So if we were to change, say, the duration to 10 seconds, and we change the behavior type to ping pong, and we also added a couple of control points, so you can think of these as your start and end position. I can add 2 of these, and then if we drop these down, you'll see that right here it's got a checkbox that says position is relative. So if I leave this first control point as 0, 0, 0 and as relative, it will mean that this will be wherever this blueprint starts, that will be the starting position right there. So we don't have to mess around, adding a certain amount to the current location times by delta seconds, blah, blah, blah. We can basically just add 2 control points, and let's say the position on this control point is 1000 for 10 meters. We can give that a try, and then if we hit play, that platform will start moving, and I may make this a little bit quicker. I'm just going to change the duration to 5 seconds and hit play, and 10 meters probably won't get it quite there. It hasn't. Whoops, I spazzed out. I was going to jump on the platform there, but I spazzed out. But as you can see, just like that, we've created a moving platform. You can jump on, and it's probably kind of good that this doesn't reach all the way, because it means that, oh no, that's still definitely way too far to jump over there. So let's actually make the duration 4 seconds, and let's make this 15 meters, 1,500. And I'm also going to, grab this platform and just make it overlap with the level a bit there. Looks like it's still stopping quite far from that other platform. Didn't quite make it. And what I might just do is just grab this and move it a little bit over there like so. Nice. And so basically, we're not making a 3D platformer here, but basically I just wanted to show you that Unreal Engine does do quite a lot of things for you. And, often there is a much, much easier way to do something that you're trying to do. And this gets me onto the next topic I want to talk about, which is discoverability. And discoverability is what this engine has in spades. So if you want to achieve different things and you want to find new nodes, etc., you can literally go into a Blueprints event graph and right click, and you can start searching for stuff. You can even, you can drag off of certain things and you can just look at what's in there, and you'll often find this section called utilities and all sorts of different stuff. So if you wanted to start messing around with, let's say, an array, you can look at different array utilities. And an array is just basically a type of variable that stores an array of other variables, if that makes any sense. I'm obviously not going into anything like that in this tutorial, but just discoverability. You can grab a component, let's say the follow camera here, and you can drag off of it, and you can type set, and you can look at all the different things that you can set inside the camera, such as set field of view. So just by dragging the camera and typing set, I've found something called set field of view. And if I plug this in, and I also select the camera and have a look at the defaults. So if I click it on the follow camera and have a look at the defaults over here, I can see that the default field of view is set to 90. So if I change this to something like 60, it's going to be a lot tighter. And then I can hit play, and if I press R, boom, my field of view has changed to 60 degrees. So a totally different field of view there. But the point is that you can find that on your own, and there is so very much that this engine can do for you. There is thousands upon thousands of blueprint nodes and different types of variables, and it really is incredibly powerful. So on that note, I just want to leave that with you. It's something that I wish I knew when I was starting out, and it could have saved me a lot of headaches with different things that I was trying to achieve in my different projects. So with that being said, let's continue on. The next thing I'd like to look at with you guys is how we can interact with other blueprints in the world and the difference between, for example, casting to another actor and by interfacing with it. And if you don't know what any of this means, don't worry too much. But basically what I'm going to do is just grab this player start and move it over onto this new platform here. We're going to start our player over here. I'm going to rotate it by 90 degrees. And I'm going to create another blueprint actor here that we're going to interact with. But first, we're going to head on over to the Unreal Marketplace. So if we click up here on the quickly add to project button right here, you'll find a link to the Unreal Marketplace. You can open it up. And in here, you'll find a bunch of different assets that have been uploaded to the marketplace for sale. You've got some free ones for the month here. You've got some ones that are on sale or, well, just showcased. And, just a bunch of different asset packs, all different sorts of things. But the brilliant thing about Unreal Marketplace when you're first starting out is that it also has a bunch of free stuff. So if you just click on free right here, you're basically filtering for free and you'll see a bunch of stuff here. You can also just search. So if I search, for example, for VFX, I might find a bunch of VFX packs. And then over here, what I can do is just filter for free. And I have found a bunch of free VFX packs. And right here you can see one called the Realistic Starter VFX Pack Volume 2. This is the one we're going to be working with today. So I want you to find this one and add it to your project. So what you'll do is you'll open it up, you will add it to your library, and you will add to project. And then what you can do is search for your project here. And if your project doesn't show up here, it's because you are using a version that's incompatible. It looks like this asset pack has been made compatible with 5.4, and I'm just going to make sure this is the correct one for me because I've made a backup copy here. So I'm going to select my project and add this to my project. If you haven't downloaded it already, it will probably need to download and then it will add to your project. And once it has, you can close this and you'll see that a new folder has been created here, Realistic Starter VFX Pack Volume 2. And if you look in here, you've got a bunch of different folders. You can go into particles and you've got a bunch of different particles here. So the one I'm going to be looking for is a lightning particle, I believe. It should be in here, maybe in environment. I think the particle effect I'm looking for is actually in a different asset pack. Sorry about that. I'm going to go back to the Unreal Marketplace. And I'm going to find this asset pack called FX Variety Pack. It should also be free for you. I'm going to hit Add to Project and find my project. And add this to my project. And now you should see a new folder, FX Variety Pack. This, I believe, is the one I was looking for. Yep. So this one has something called P_KY_lightning 3. And this is the particle that I'm going to use right here. Sorry about that, but now you've got 2 VFX packs added to your project. So if you want to go on and play around, you might find some fun stuff to do with that. So the next thing we're going to do is create a new blueprint actor. So I'm just going to create this one in the content folder again, right here with my BP platform. I'm going to right click and go to blueprint class of type actor. And I'm going to call this BP_lightning pad, something like that. I'm going to open this up, and the first component I'm going to add is just a plane, and this is basically just going to show me where this blueprint is. I'm going to bring this up just a smidge, and I'm going to scale it up in the X and Y so that it's a little bit bigger. like so. And I also need a collision box so that we can overlap with this actor more easily. I can add a component and search for box, and you'll see box collision. I can choose this, and then I'm just going to move it up a little bit. Make sure that the bottom is going through that plane, and I'm going to scale this up so it's bigger than the plane, like so. And now what I want to do is compile and save and go to the event graph. And I'm going to create some very, very quick logic that will spawn this particle effect when we interact with this blueprint. So what we can do is right click and search for custom and add a custom event. And this is basically an event like these others that you've created and that you can call from elsewhere in your logic. So these are very, very useful. You will use them. What I might do is just call this spawn lightning, like so. And off of spawn lightning, I'm going to find a node called spawn emitter at location. So this will spawn our lightning effect, and you could browse through all of the effects here that you have available to you. That is one way. Another way is that you can go into your folder, find the effect that you want to use or any type of asset. You can click it and select it, and then go back into your blueprint and click this little arrow icon, which, as you can see, uses asset browser selection. So if I click that, it has set this as the asset that I had selected in here, like so. And the location that we're going to use is just the center of our plane. So I can grab my plane from the components tab, and I can get world location and plug this into the location like so. Now I'm going to show you a very, very quick way of interacting with this blueprint. So if I go to my content folder, find my lightning pad, and just drop it here in front of my player start, like so. What I want to do is call this, I'm just going to close BP platform there. What I want to do is call this lightning pad spawn lightning custom event from my character. So I first need to basically find a way of communicating with this blueprint from this other blueprint, which is my character. And I'm just going to use the R key here on my character. I'm going to delete this field of view node that we played around with. And what I'm going to do is right click here and get overlapping actors. Now this, we can get any actors that our character is overlapping with in the world. And we can change the class filter here and look for our lightning pad, BP lightning pad. And off of overlapping actors here, you can see these little squares. This denotes an array, so an array of actors. And we can drag off of this and just find this node get a copy. So, and basically this is the index of which overlapping lightning pad we want to interact with. And if this is set to 0, basically what this is doing is getting the first overlapping actor of type lightning pad. I hope that's not too confusing for you, but it doesn't matter too much. We're just getting the first overlapping actor of type lightning pad, and we're using this object reference to cast, so we can cast to our BP lightning pad. And basically this allows us to do anything inside of that blueprint lightning pad from here. So we can drag off of as BP lightning pad, and is it spawn lightning that we called it? What did we call it? Spawn lightning. And you can see it says call function, and it has this little icon for an event. So we are calling the function spawn lightning, which is the custom event that we made inside of that blueprint. So what we can do now is we can hit play and we can go over, and when we are overlapping with this actor, if we hit R, it is spawning that lightning effect like so. And if we're not overlapping with it and I press R, nothing will happen. So as soon as we overlap it and we press R, we are able to call that function. So this is our character blueprint, and it is interacting with this lightning pad blueprint and calling that spawn lightning function via something called a cast. Now, this is a very important thing I want to touch on with you guys as beginners. A lot of tutorials will ask you to cast, always casting to any other objects that you're trying to interact with. And this is not by default the wrong way to do it, but what you need to know about casting is that casting creates a permanent reference, a hard reference to that blueprint. So for example, if I want to run around in this world and do a bunch of different stuff and I never touch this lightning pad, I don't want my character to be containing a hard reference to this lightning pad. There are examples of where casting is sort of appropriate. For example, to and from an animation blueprint, which I'll go through with you in a moment. But casting to this lightning pad is quite silly, frankly. So we want a different way of doing that. And another way of doing it is using a blueprint interface. So what I can do here in my content folder is I can right click and go to blueprint and blueprint interface. And I'm going to create a new blueprint interface. I'll call it BPI for blueprint interface underscore interact, like so. And if I open up blueprint interface interact, you'll see it very quickly asks us to rename the first function. And I'm just going to call that function interact, like so. Now, basically what a blueprint interface is a way of different blueprints sharing functions. So if I want my character to share the function call lightning with my lightning pad blueprint, I can use a blueprint interface, and you can give these functions inputs and outputs here to pass data between those two blueprints. We're not going to be doing that here because we don't need to. We're just opening this up and renaming this function interact, and then we can compile and save and close that. And then inside of our BP lightning pad, we can go to class settings, and over here in class settings, you'll see interfaces, implemented interfaces. I can click add, and I can find the BPI interact that we just created and add it to this blueprint. If I hit compile and save now and look down here in my blueprint, there is an interfaces section, and if I drop this down, there is now an interact interface right here. So what I can do is I can right click on this and I can either go implement event, or I can simply double click on this interact and it will create this event in the event graph with this little blueprint interface icon here, and I can delete spawn lightning and just plug in event interact here, and then compile and save and go to my third person character, and instead of casting here and calling spawn lightning, I can just get my BP lightning pad overlapping actor and I can interact with it. And you can see here under BPI interact, there is the interact message. And this is basically going to send a message out to the first overlapping actor of type lightning pad and call that interact function right here. And this prevents my character from storing a hard reference to the lightning pad in my character's blueprint when it doesn't need to. So now when I overlap and I press R, I can still call that lightning, but because I'm not casting to that lightning pad, I can run off and go to other parts of the world, other levels, and my character won't be carrying around this reference to a lightning pad when it doesn't really need to. So that's a very important thing that I think beginners need to know and is not really talked about very much in beginners tutorials. They just constantly tell you to cast, and sometimes that can be a very, sort of quick and hacky way to set things up without needing to create a blueprint interface and add it into the class settings of the blueprint, blah, blah, blah. Sometimes it is just appropriate to cast in a beginner's blueprint. I'm not trying to, I'm not trying to talk crap about other content creators who make tutorials that tell you to cast. I also do it. But if you're making your own project and you've got this sort of interaction between multiple blueprints in your game, and there is no reason to create a hard reference as you do when you do a cast, then you shouldn't do that. You should use something like an blueprint interface or an event dispatcher. I'm not going to be talking about event dispatchers in this tutorial, but it is just another way of sort of communicating between blueprints, and that has its own uses as well. So with all that being said, what I want to do now is look at animation blueprints with you guys, and I just want to sort of give you a quick rundown of how they work. So if I go to my BP third person character here and go to the viewport, I'm just actually going to delete that cube because it's a little bit distracting. And I'm also going to go to the event graph, and I'm going to delete all this stuff to do with the cube because I'll probably get errors if I try to compile and there is no cube to rotate. So I'll go back to my viewport here and look at my character. And you see my character is animated here in the blueprint. She's doing an idle animation. And if I select that character mesh and look over here in the details panel, you'll see that the animation mode is set to use animation blueprint, and the anim class is ABP Quinn C. Now I'm going to browse to this ABP Quinn C, and I'm going to open it up. And the very first thing that you'll notice when you open up ABP Quinn C is that there is basically nothing in here, and we've got this comment that says this is a child NMBP, a child of ABP many. That means it uses the logic and graph of another NMBP, but can override sequence and blend space players in the asset override, blah, 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 blah. So child NMBPs are great if you have multiple characters with different animations, but want to share logic. So basically what this is saying is that Quinn's animation blueprint is a child of Manny's animation blueprint, and it just uses a couple of different animations. So if the characters have all of the exact same functionality, but you want them to have slightly different animations, you can have a child of an animation blueprint for that purpose. So this one is basically just got a few different animations, but it shares all the same logic. And to simplify this a little bit, what I want to do is go to my third person character, select the mesh here, and over here in skeletal mesh asset, I'm going to change this from SKM Quinn simple to SKM Manny simple. I'm going to change this for Manny, and at the moment Manny is using Quinn's animation blueprint, so he's got the more sort of feminine animations in certain places, such as the idle and the running and whatnot. So I'm going to change the anim class here to ABP Manny, and now you can see his stance has slightly changed. And if I compile and save and hit play, I now have Manny as my skeletal mesh, and he has slightly different animations. Because obviously, yes, he's a man. He's a man robot. So what I want to look at with you guys is just basically an animation blueprint and what it's doing. And the reason I changed this to Manny is because it can be a bit confusing to say that ABP Quinn is a child of Manny, and we're going to look at Manny's animation blueprint, but your character is Quinn. We're just going to change the character to Manny, and we're going to change his animation blueprint to Manny's animation blueprint, and then we're going to open up that blueprint here, ABP Manny. And the first thing you'll see is the event graph here. And this is basically what's happening here is you've got this window up here that says set references to owning character when this blueprint initializes. So you can see here, event blueprint initialize animation. This is basically like event blueprint begin play in our character. Event blueprint begin play. This is basically like that. So when this blueprint initializes, what this is doing is casting to a character, and it's getting the owning actor of this animation blueprint as the object reference to cast to that character, and then it's basically setting a variable, and this variable is a reference to that character. So this just allows us to grab the character in other parts of the blueprint. Down here in the variables and references, you can see character. I can get that, and then I can get stuff from my character and use it in here. And it's also getting the movement component. So as we talked about earlier, the character movement component here, it's getting that, and it's also setting a variable called movement component, which is also a reference to this character's movement component. So, if you wanted to get the gravity scale or something, you could get the movement component and get gravity scale, whatever, get gravity direction, this is just creating a reference to the movement component. So it's doing this when it starts up, and then down here you've got only update values if the character is valid, character exists in the world, and the reference is set. So that's what this is. This is called a validated get. Basically what this is they are getting the character reference, and then if I right click on this and convert to validated get, you see it now has execution pins, and it has output pins that are is valid and is not valid. So if you wanted this logic to only execute when the character is valid, you can get a validated get and do that. And basically what event blueprint update animation is basically event tick. You can think of it like our event tick, which I've deleted now. So this is running, and every time that it runs, it is executing this sequence. And the sequence executes all these pins one by one. So it executes this one, and then it executes this one, and then it executes this one. And this is happening many times per second. It's going boom, 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 and executing all of this logic. And what this logic is it's getting data from our character as it moves through the world, and stores it as its own variable. So if I drop down this variable section down here, essential movement data, it's basically, we've just put all these variables into a category here, essential movement data, the velocity, the ground speed, should move, is falling, and basically that's all this is doing here. So many times a second, it's checking the character's velocity as you walk around the world, and it's setting a variable called velocity. It's also getting vector length on the X and the Y, which it is saving as ground speed. So this is the length of a vector on the X and Y axes, saved as a float, I believe. Ground speed float. And this just gives us the speed of the character, which can also be used to dictate which animations play. So that's what this is doing. It's getting velocity, ground speed, is the character falling, which is just inside the movement component. Is the character actually touching the ground, or is it in the air to, do jumping and falling animations? It's getting all this data many times a second and then using it to dictate which animations play inside the animation blueprint. And you can see those animations by going to the anim graph here. So this is the event graph, but the animation blueprint also has an anim graph. You can click it here, or you can double click it over here in animation graphs and go to the anim graph. And basically the anim graph I'm going to go into these in a moment and sort of show you what's going on in there. But basically all of this stuff connects into this output pose, and the output pose is what is played on the character. So very, very quickly, this is just for feet IK. So if I compile this blueprint and I get my player start and move it over here, and I hit play, and I go over to this little ramp here, and I sort of put 1 foot on and 1 foot off. I'm going to press F8 to eject here. You'll see that his foot is kind of sitting up on that ramp, and the other one is on the surface below. And this is what's known as feet IK. So that's what that node is doing there. What I can do is I can actually just delete that node. If I delete these nodes and plug this in here and hit compile and save, you'll see the difference for when we don't have feet IK. So it's not able to sort of place the feet on different surfaces now. It's just going to float sort of on that middle point where the capsule component is sitting. It's just going to put the feet there, which is fine if you're on a flat surface, but I'm just going to press Control Z a few times to undo that. Oh no, I'm not. It's not letting me, but that's okay. So we've just deleted the feet, okay, just to give you a quick demonstration there. Now, what's going on here is you can see these nodes have this writing here that says state machine. And these are state machines. And state machines basically have a variety of states inside them. So if I open up locomotion here, it only has 2. So this is a good example to start off with. These are states, and one is called idle and one is called walk run. And you can see we've got these arrows between them, and then these little icons next to the arrows. And if I double click on this icon, you'll see that this result here is a Boolean called can enter transition. And we've got a variable plugged into it called should move right here. And remember, all of these variables are set in the event graph. So if I go back to the event graph and I find where should move is set right here, we've got a little comment that says set should move to true only if ground speed is above a small threshold to prevent incredibly small velocities from triggering animations, and if there is currently acceleration and input applied. So what this is doing is checking, is the ground speed greater than some very small number, 3 centimeters, and is the current acceleration in the movement component not equal to 0. So if we're pressing a movement key and our ground speed is greater than some small number, it's setting this Boolean should move. And basically what this is designed to do is to check for very small changes in the ground speed and make sure that, and up here we can see a little rundown of, it's basically a directory. We are in ABP Mani, anim graph, locomotion, and the idle walk run state. So we can back out to locomotion here. And so basically what this is saying is if we can transition from idle to the walk run state by this Boolean that is set in the event graph here. And if we open this other one, you'll see it says should move is connected to a not Boolean, and that is connected to the can enter transition. So we can enter the transition if we are not moving, if we shouldn't move, if that makes any sense. And basically what these states contain is animations. So if we go into the idle state, we've got idle sequence player here. If we click on that and select the details panel here, we can see that in sequence here, it has idle selected here. So this is the idle animation. We could browse to this, and we've got a bunch of different animations here. We could open up idle, and then we can see this is the idle animation right here. So this idle state is just the idle animation on loop. So that's the other thing you can notice if you select the sequence player and look over here, it says loop animation. So this is looping, looping, looping. You can tell by this progress bar is just going back to the start and looping. And if we go back to locomotion and go into walk run, we'll see a different kind of node here called a blend space player. And this is playing a blend space called BSMM walk run based off of this variable ground speed. So we can find the blend space over here as I just did with the idle, or you can simply just double click on this node and it will open the blend space. And this is basically, this is a single axis blend space that takes the ground speed and uses it to blend between different animations. If I highlight these little diamonds on the graph here, you can see this one says walk in place, walk in place. This one says walk forward, and this one says run forward. And if I hold control and highlight this line on the graph, you can see a preview of the blend of those animations. And you can see on the little box there where my cursor is, it says speed. So based on a float called speed, it will blend between these three different animations. And once again, it is using ground speed, which in the event graph is set right here on the vector length XY. So many times a second, this is being set and updated from our character and then used in the anim graph to output a blend from this blend space of walk run. So that is basically a very quick introduction to state machines and transitional rules. But if I back out to the anim graph here, you'll find one here called main states. And if we open up main states, you'll see it has a couple more states than our locomotion. And it has just a little bit more going on. So basically, what we've got here is locomotion, which is this state machine, is saved right here in a cache. This is a cache, so basically this saves the output of locomotion. And then within main states, what they've done is they've accessed that cached pose locomotion. So whatever that locomotion state machine outputs, that's what this state is going to output. So if we go into it, you can see that use cached pose locomotion, and it's just outputting whatever that locomotion outputs. And we've got a bunch of transitional rules into jumping and falling and landing. And basically, so all of these transitional rules, you can go into them and see, is falling dictates this one. This one, I believe, is automatic. So if we click on it, you'll see this checkbox automatic rule based on sequence, blah, 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 blah. Basically, when the jump animation is completed, it will transition into a falling animation. And the only other thing I want to point out here is that these two falling and two land states are actually, they've got a slightly different icon here with the transitional rule icon right here. And that's because these are actually state aliases. So these kind of act like states, but instead of transitioning from this animation to jump and this animation to jump or landing, whoops, didn't mean to do that. What they've done is they've used a state alias, and if we click on it, you can see here it's got a list of the different states, and they are checked if you're able to transition here from those states. So to falling, to jump, and to fall loop is able to be transitioned to from locomotion and land. Now, I know this might sound a bit confusing, and don't get too bogged down on these state aliases. I just wanted to give you a quick introduction and just try to explain to you what's going on here. So to land, basically land can be transitioned to from jump and fall loop. So obviously the only way you can land is if you're in the air. So if you're in either of these states, jump or fall loop, and you satisfy this transitional rule is not falling, then you're able to transition into the land animation, the landing animation. So yeah, that's pretty much all I wanted to go through with you guys. And one last thing I'll point out is this slot default slot. So this is for something called an animation montage. And if you wanted to play an animation on your character, but it doesn't really warrant having a state inside of a state machine, what you can do is create an animation montage and you can play it on your character and it will slot it into an appropriate slot. So you can have these in different groups. You can see this one says group default group, and it basically just means that I've only got this one slot for animation montages, and any animation montage I play on my character will play on this slot. So, that's stuff like a reloading animation or a firing animation or something like that. Something that isn't really a state, but is more just of an action, like a very quick action. You just want to play it as a montage. That's what that's for. Alrighty guys, I hope this tutorial has been of some use to you. If it has been of any use or value to you whatsoever, please hit like and subscribe. And if you're interested in learning more and going forward, I do have some other tutorials designed for beginners in the early stages of learning Unreal Engine 5. So if you're interested in continuing to learn Unreal Engine 5 with me, I will leave a link to a couple of other tutorials of mine in the description, and if you'd like to check those out, I've been getting some really great feedback about how much they've taught beginners. So yeah, I'd be excited for you to check those out. I've also got a link to my Patreon in the description, and for a limited time I am offering the first 150 people to buy a $10 membership on my Patreon. I am offering them lifetime access to my Discord server, Mizzo's Dizzo, even if you immediately cancel your Patreon membership. So with just one payment of $10, you will get lifetime access to Mizzo's Dizzo, which I'm hoping to sort of build as a tight-knit community where you guys can interact with each other and reach out for help if you need. We've also got some casual sort of hangout chat channels on there. We can talk about what games you're playing or whatever you like. I think it's pretty cool. It's growing every day. I hope to see you there, and I hope to see you on the next one. Thanks for watching.